Yeah. So we continue with solving quadratic equation use factorization. So I'm going to do a little bit of review, okay? First, so when you got x squared equal to 4, what would be the answer?
X would be 2.
2 or
4.
Yeah, for quadratic equations, you actually have 2 solutions. So the other one will be -2.
Ah, -2, yeah.
Right, people tends to forget, yeah, we got positive and negative numbers. Now, x squared equal to 9, what would be?
3 or -3.
3 or -3. And we write this as ±3. Good?
Okay.
And this one we use that ±2. So that's just kind of shorthand. Okay, and what's going on here actually is because we are using an identity called a plus b times a minus b. Remember what this is?
Was it the identity law?
There's identity, yeah, for this one. A plus b times a minus b is equal to a squared minus b squared. Good? Yeah, there are 3 identities that when you study algebra, you need to basically memorize that. So I'm going to write it again. One is this, a plus b squared, which of course is a plus b times a plus b. And that gives you a squared plus 2ab plus b squared. Good?
Okay.
And another one is a minus b squared, which is basically a minus b times a minus b. And that gave us a squared minus 2ab plus b squared. Good?
Okay.
And last one is a plus b times a minus b. That's a squared minus b squared. Good?
Okay.
Yeah. If you sometimes don't remember exactly, you can still work it out because what is a plus b times a plus b? Remember the FOIL we talked about before?
Yes.
Okay, so that means a times a squared. Then a times b is plus ab. Then plus b times a is the same as a times b. Then b times b is b squared. So therefore, what we got is a squared plus 2ab plus b squared. Good? Yeah, you can do the same thing. You can also work out those identities. So this actually in algebra, we are going to use that a lot. So the kind of basic, kind of like our basic building block. So we have this one. And we also have, we said a minus b squared is equal to a squared minus 2ab plus b squared. And lastly is that. So this is those famous 3 identities. Okay, a plus b times a minus b equal to a squared minus b squared. Okay, a lot of times you will use that to play tricks. Okay, now what's happening here is this, a squared equal to 9, which is the same as a squared minus 9 equal to 0, right? Now 9 is 3 squared. So based on the last one, based on this, we can write that as x plus 3 times x minus 3 equal to 0. Good?
Got it.
Yeah, so basically, so the left-hand side is this, right-hand side is means 0. Okay, now we have something. This is something like when you have two numbers multiply, let's say we got A times B equals to 0. Basically just says a number times another number is 0. What could happen? Now, either A is 0, right? If A is 0, doesn't matter what B is. I mean, A 0 times anything is 0. So that is one possibility. Or B is 0, right? That's another possibility that when B is 0, it doesn't matter what A is. And or A and B both are 0. Good?
Got it.
So because this is called the zero product property, one of the basic fundamental properties in algebra, they call the zero product property. And we actually in math, we use that property a lot. Okay, which now we have exactly the same thing. We got x3 times x minus 3 is equal to 0, which means either x plus 3 is 0 or x minus 3 is 0, right? And the top give us x equal to -3 because it's an x plus 0 is 3, then x has to be -3. And on this one here, the x is 3. So therefore, our answer for that then is 3 or -3. We write as plus minus 3. Okay. So that's basically the reason why
Excuse me.
we have that. Okay. Now, based on that, then we can have a formula. I think we talked about formula is x squared equal to c. We can write as x squared minus c equal to 0. Then c we can write as square root of c squared, right? Now we good here?
Yep.
And this, based on this identity, we know is x plus square root of c times x minus square root of c equal to 0. Then based on our zero product property, then we know either x plus that equal to 0, which gave us minus square root of c, or x minus square root of c equal to 0, then that gives us x equals square root of c. So if we have something like this, our answer would be x equal to plus minus square root of c. So now we have something called a formula. So next time when we see something like this, like x squared equal to 4, we just plug in the formula. In this case, x is plus minus square root of 4, which gives us plus minus 2. Okay?
Okay, got it.
Okay. Now from that, we're going to move on to something like this. X squared plus 3x equal to 0. So what do we do on that one? Well, here we notice x squared is x times x. And that we know we can change that to, we can move x out. Good? Are we good here?
Yes.
Okay, so if this is 0, then same thing, the 0 for the zero product property. It's like two number multiply equal to 0, we use that property. So that could be either x equal to 0 or x plus 3 equal to 0, then x equal to -3. Good?
Okay.
So we'll still use that. So this kind of problem is easy because we can always move x out. Then we can solve that pretty easily. Or same thing like this, x squared minus 4x equal to 0. We know we can move x out, so it becomes x minus 5 equal to 0. So x is either 0 or x minus 5 is 0. So x is 5. Good?
Mhm.
Okay. So I'm going to give you just a couple to practice on, okay?
Okay.
X squared plus 4x equal to 0. What's our solution?
So either x would equal 0
Mm-hmm.
or x minus 4 would equal 0.
Oh, x plus 4 equal to 0.
Oh, yeah.
Because this one is x plus 4, right?
Mm-hmm.
Good.
Yeah.
Now, if x plus 4 is 0, what is our x?
It could be -4.
Right, x is -4. Very good. Now we do x squared minus 5x equal to 0. So what we got?
We could do so either x minus 5, sorry,
Yeah,
would be equal to 0, which would mean that x would be 5.
right. Or x equal to 0, right?
Yes.
Okay, very good. I'll give you just what happens if you have something like this.
2x squared plus, whoa.
Well, the same thing we do, right? Move the x out. Good.
Okay.
Which means either x is 0 or 2x plus 6 is 0. Now, this is just linear function. We can solve that, right?
Yeah.
And that give us what x is.
6, that'd be 2 times x. Could be 12?
No, because from here, how do we solve this problem? -6 on both sides, right?
Oh, yes, the minus. I completely forgot about that.
Yeah, there's 2x equal to -6, right?
X equal to -6. So
Then we divide by 2 on both sides. That cancels. So x is.
that should be -3.
Yep. Good.
Yeah, that makes sense.
Solving a linear equation here. Okay. Let's give another one. So how about 2x squared minus 5x equal to 0? How do we solve that?
So x plus 2x -5. So if it was like that and it was like that, you subtract 5 on both sides. So it'd be 2x is equal to -5. It would be the square root of the positive square root of -5.
No, we don't have square root here because it's 2x minus 5 equal to 0, right?
Oh, so you'd be adding 5. So it'd be a +5.
Yeah. And we got 2x equal to 5. What's our x then?
5. X would be equal to 5/2.
Yep.
Okay.
Good.
Yeah, I understand that.
What we did here is we actually break this complex problem into 2 linear equations. So we break something complex into something simple. Good. That is a very common technique how to solve problems, is they break a complex problem into simpler problems. Good.
Okay, that makes sense.
Okay, just do one more here. 3x squared plus 7x equal to 0.
X, 3x plus 7 minus 7 minus 7. So going from 3x squared plus 7x equals 0, we can go to x equals 3x plus 7, subtract 7 on both sides. That would be 3x is equal to negative 7.
Right.
To divide them both by 3, that would be x be equal to negative 7/3.
Perfect. Very good. So that's how we solve this kind of problem. And then we're going to get something a bit interesting, a little bit harder, is that what happens if you have x squared plus 3x plus 2? Well, 1 equal to 0. So one thing we can see, well, we're going to play some tricks. We can break this down into x squared plus 2x plus x plus 2, right?
Okay.
Good.
So, yeah.
Break the 3 into 2 part.
Oh, okay. Yeah.
3x to 2x plus 1. Well, we move this out, we got x over x plus 2, right? Good.
Yeah.
From that. But on this side, we already have x plus 2. So now x plus 2 is the common factor, so we can move out. And we can move out is x plus 2 times x plus 1 equal to 0. Good.
Okay.
So basically saying this is equal to that. I mean, the whole thing here is to prove that. Good.
All right.
Yeah. So what we're playing is we take the common factor, we move it out. For example, 4x plus 8, we can write as 4x plus 2, right?
Okay.
Good.
Yes, that makes sense.
So once we got that, we know either x plus 2 equal to 0, which give us x equal to -2, or x plus 1 equal to 0, and that give us x equal to -1. Good.
Okay, yeah, that makes sense.
So I will find the solution. And we actually can check it. This is called evaluation. So what we did here from here to there is to find the solution. And to checking it, that's called verification. We basically plug in x equal to -2 here and see if it's 0, or x equal to -1 back to here and see if it's 0. Good.
Okay.
So that is called verification. Sometimes I say verify the solution. This means you have to plug in to the original. This is the original problem. So if we plug in x equal to -1, we'll see -1 squared plus 3 times -1 plus 2. And -1 squared is 1. 3 times -1 is -3 plus 2. That's -2 plus 2, that's 0. Okay, we know this is a solution. The -1 then is plug in -2. So what we got? -2 squared plus 3, -2 plus 2. So -2 squared is 4. 3 times -2 is -6 plus 2. That is 4 minus 6 is -2. -2 plus 2 is 0. So we know this is also a right solution. Good.
Okay.
Yeah. So I'm going to show you one more, okay? This kind of problem is x squared plus 2x minus 3 equal to 0. How do we solve that one? That actually we can see same thing. We're going to break that because x squared, we break 2x into 3x minus x. Good.
Okay.
Okay, the reason we do that, you can see here now, this, we take x out, is x times x plus 3, right?
Okay.
On this side is minus x plus 3, right?
Uh-huh.
Now, this is the common factor, so we can take that out, is x plus 3 and x minus 1, right?
Uh-huh.
Now we know this is equal to 0, so therefore, either x plus 3 equal to 0, that give us x equal to -3, or x minus 1 equal to 0, that give us x equal to 1. Good?
Okay.
Okay, now we're going to go back to check it.
Mhm.
So x equal to 1, 1 square plus 2 times 1 minus 3. All we know is 1 plus 2 minus 3. That's indeed 3 minus 3. That's 0. Another one is -3 squared plus 2, -3 minus 3, and equal to -3 squared is 9. 2 times -3 is -6, and minus 3. And 9 minus 6 is 3 minus 3 is equal to 0. So we know those are the right solutions.
Right.
Good?
Yep. Got it.
Yeah, and this actually is a common technique in algebra, is to break something into two parts. So, I mean, the trick here is we break the 2x into 3x minus 1. Good? Or
Okay.
minus x, right? Minus 1x. Good? We know 3x minus x is 2x, right?
Yes.
And now we can see that there is a 3 here, and here we also have 3 there. So now we move this out, is x plus 3 on this side, and minus x plus 3. Now we see that this become the common factor, right? Good.
Okay. Yes, that makes sense.
Yeah, then we just move that out. Then what's got in is this left. And this minus that is just basically -1. Good.
Yes, see.
We are not sure, we can always check going backwards. This times this is x times x plus 3, right? And
Yes.
this times that is minus x plus 3, right? Get the distributive property, right? That's something we learned. So therefore, yeah, basically we just do that kind of in a reverse way. But the thing is, what we are trying to get on is, once we change it to this, then that becomes, we just solve two linear equations, because based on the zero product property, either x plus 3 is 0 or x minus 1 is 0. And both are linear functions that we can easily solve. Good? All right, so I'll see you next time, okay?
All right. See you.
Next week.
Thank you.
You're welcome. Bye.